I wanted to record a quick video for special right triangles. So in this section, we're going to be looking at 45, 45, 90 triangles and also 30, 60, 90. So let's take a 45, 45, 90. We know a few things. We know it's a right triangle, but we also know it's isosceles because of the base angles being congruent. So let's say, for instance, that one of the legs is 6 inches. We know the other leg would have to be 6 inches. And if we needed to solve for the hypotenuse, then we could just use the Pythagorean theorem. So 6 squared plus 6 squared is going to equal c squared. And so what that tells us is that c squared is 72. But we want just c, so we're going to take the square root, which would be plus or minus the square root of 72. But then we could break that apart into 36 times 2, which is going to be 6 root 2. Now in this case, we wouldn't include the negative solution because it is a length or a side. So we would only include the 6 root 2. Now what I wanted you to see, or what I wanted to talk about, is there's always this pattern. So anytime you have 45, 45, 90 triangles, we can see a pattern. So for instance, if this was 4 centimeters and this is 4 centimeters, you can do the Pythagorean theorem to check, but the hypotenuse is always going to end up at 4 root 2. Which means if we want to generalize the theorem, I'm going to call the side, the leg, x, and which means the other leg would be x. And then we could call the hypotenuse x times root 2, or x root 2. So that will be super helpful if we want to solve problems a little quicker. You can always use the Pythagorean theorem with 45, 45, 90, but it just helps. Now I do want to mention when you're going from this leg, let's see here, to the hypotenuse, notice you're multiplying by root 2. But if you have to go from the hypotenuse to the leg, you're actually doing the opposite operation. You're dividing by root 2. So let's take, for instance, I'm going to grab another one of these triangles. And let's say that the hypotenuse is 3 root 2. If we were to move backwards to a leg, we would say that it would have to be 3 root 2 divided by root 2. Well, these are both monomials, and so we can simplify monomials. And root 2 over root 2, that's really the same as 1 over 1. So that leg is going to simplify to 3. Now, we are going to work with harder problems. Let me grab this other one, where let's say the hypotenuse is 16. So if we were to work backwards to get a leg here, we would still do 16 divided by root 2. This is an answer. We typically don't leave it like this, at least in geometry and algebra 2. We will rationalize the denominator. And what that means is just you can't leave the square root on the bottom. So we can multiply by root 2 over root 2 because that's the same as 1. And we're left with 16 root 2 over 2. Now this will go even further. Since it's a monomial over monomial, we can actually reduce this 16 over 2 into 8 over 1. So this side ends up being 8 root 2, which is also this leg, 8 root 2. And you can always check it by multiplying the hypotenuse multiplying the leg by root 2 to see if you get the hypotenuse, which would be 16.